Hey guys, Mr. Milton here. Today we're going to look at triangle angle sum theorem notes. At the end of this video, you should be able to use the two theorems to find the missing angle measures in triangles, and you should be able to classify triangles by angles and by sides. All right, so here's the main theorem. Today, the triangle angle sum theorem, and it states the measure of the angles in any triangle add up to 180 degrees. Okay. Adds up to 180 degrees. That is the big thing. We'll use this knowledge to build off of for the rest of this chapter when we talk about polygons. Big deal, 180. Keep it straight in your head. Okay, so let's use that information in this example. They ask us to find the measure of angle 1. They give us two angles in a triangle. And so since we know triangle angle sum theorem says that all triangles have to add up to 180, we do some simple math here. 100 plus 48 plus the measure of angle 1, I'll just call it x, equals 180. Okay. So subtract 148 from both sides, and we find out that x must be 32 degrees. Okay. Pretty simple. Let's look at it a little bit more involved problem. Okay. Okay, so here we have a couple of triangles. I guess I can see three triangles here, and they're asking us to find x, y, and z. Remember for these problems, not to get stuck trying to find it in order. As I look, like I said, we have three triangles. We have a triangle here, we have a triangle here, and we have the large triangle. You might approach this a couple different ways. So first thing that my eye sees is this triangle here. And in this triangle, I see that we have two angles already given to us, 21 and 32. And so since we have 21 and 32 already given to us, then we can use our triangle angle sum to say, okay, 21 plus 32, that's 53 degrees. 53 plus y should equal 180. Subtract 53 from both sides. That gives us 127. So then we find out that y is 127 degrees. All right. Now we need to find x and z. And we're going to use some other information that we should know from our last couple sections, right? Is that since we know that y is 127 degrees here, with x, it's a linear pair. Okay, these two angles make up a straight line. And so again, I can see that these two angles add up to 180. They're supplementary. So I use a different color just so we can mark it and see where the work came from. Okay, so for x then, we can say, okay, x plus 127 is 180 degrees. Okay. And that's because, again, they're linear pairs. And so that gives us 53. So x equals 53 degrees. List that here. And now as we look at this last triangle that we can see here, in this last triangle here, then we see that, okay, this should add up to 180 as well. We have z over here, so 53 plus 57, that's 110. So 110 plus z equals 180, and so z then must be 70. Okay, so there, use the triangle angle sum theorem a couple times, and then also integrating some knowledge about our angle pairs that we've talked about for a couple sections now. All right, second theorem, the triangle exterior angle theorem. And this triangle exterior angle theorem says the measure of each exterior angle of a triangle equals the sum of the measures of its two remote interior angles. Okay, and I still remember learning this in high school, and this is what my high school teacher showed me, so I'll show you guys because it must have worked, I guess. Okay, so remote interior angle, this is a new word for us really because we haven't had to use it before. But the way it was explained to me is if for this angle was changing the channel, you call the remote interior angles the angles that you'd have to use the remote for, right? So if we had TVs in here, like this angle's right next to it, she'd do the TVs like this because they had antennas on it then. Okay, so if you're changing the channel to these angles, 4 wouldn't have to use a remote. For 3, it's right there. Okay, so it's not a remote interior angle. It would have to use a remote for 1 and 2. So as we look and see, okay, which ones are the remote interior angles? The ones that it does not touch, it's not adjacent to it. So for angle 4, its remote interior angles are 1 and 2. And that's why our theorem here is written as the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. Again, our theorem, the exterior angle, angle 4, should equal the sum of its remote interior angles, 1 and 2. Okay, let's look at that in an example on the next page. All right. So here it says find the measures of each angle of the triangle. And what they've given us is that this angle is 100 and that these two angles are 6x plus 5 and 9x minus 10 respectively. Okay, so they gave us these angles as CAB, ACB, ABC. We should be able to identify those pretty good just because we know how to name angles. So what I want to do is before I worry about answering this question, I'm going to solve it here. This measure of angle, or measure here, angle 100, should be the sum of its remote interior angles. That's here and here. So I have an equation to set up. 6x plus 5 plus 9x minus 10 should equal the exterior angle 100. So now as we combine like terms, we have 15x minus 5 equals 100. Add 5 to both sides. 15x equals 105. And that is 7. So we find that x is 7. Guess I can continue it here. Okay. So x is 7. Great. Now that we have that solved for x, we can just plug that into these equations here. 6 times 7 plus 5, that's 42 plus 5 is 47. 9 times 7 minus 10, that's 63 minus 10, 53. Okay, and then our triangle angle sum theorem, all 3 of these angles should add up to 180 degrees. So that's 100. This must be 80 then. Which makes sense because since this is 100 and they make up a linear pair, they should add up to 180 degrees. So now just making sure that we're organized and labeling all these things right. CAB, CAB talks of this angle here. It's 47 degrees. ACB here, 53 degrees. And then ABC, this angle here inside, it's 80 degrees. Okay, so those are the angle sum theorems. And now let's look at some vocabulary that you're probably at least somewhat familiar with, but we've got to make sure that we just revisit it so that we the expectation of knowing it's there and you have resources for it. So there are a few ways that we can classify our triangles. We can classify them by their sides, and we can classify them by their angles. By their sides, if we have a triangle with all the sides congruent, we will call that an equilateral triangle. Equilateral. Okay, equilateral sides. Equal sides. Equilateral. Okay. If exactly 2 of the sides are congruent, okay, we will call that an isosceles triangle. Isosceles. You don't really say isosceles, but that's how I remember to spell it. Isosceles right there. Okay. And if no sides are congruent, we call that a scalene triangle. Okay, so pictures might help you out a little bit. I know they help me. So equilateral, you might see a triangle that has a marking like this, one dash on all sides. An isosceles triangle, have my shapes on, so they're gonna make it a shape. But you'll see just two sides marked as congruent and not a third side. And then for a scalene triangle, which I hope they don't make too bad here. No, they didn't change it at all. Must have messed up. So that's not a triangle. Let's see, did that work out? Nope, it didn't. Okay, but anyway, here we'll have three different shapes, lengths of sides. Okay. All right, but it's a scalene triangle. All right, by their angles. If all angles are congruent, we'll call that triangle equiangular. Or do we call it regular? No, equiangular. I said it right. Angular. Let me put this vocabulary term in here. If a triangle is equilateral and equiangular, then we'll call it regular. Okay, so get used to the word regular, meaning that all sides and angles are the same. It doesn't mean like what you're used to. It means all sides and all angles are the same. Okay, if all angles are acute, we call it an acute triangle. Remember, acute means that their measures of the angles are less than 90. If we have one right angle, the other two are acute, right? Because that has to be it. Can't have, if we have 90, we can't have another one above 90 because that would add up to more than 180. Okay, so one right angle, we call that a right triangle. Right triangle. And then if we have one obtuse angle, the other two again would be acute because same logic with our right angle. We call it an obtuse triangle. Okay. All right. Again, we can classify triangles by their sides and by their angles. Okay. So here it says to classify each triangle, and they gave us three: MPR, MNP, and MNR. So before we jump into it, what we're given here is their angle measures. Okay, so we will not be able to classify these by their side lengths as of now. Okay, we just don't have enough information. So let's fill in the rest of these angle measures. Since this is 73 degrees, and this is showing that it's a right angle, we can say, okay, this angle would be 17. Now we use our triangle angle sum theorem and say, okay, 17, 62. The rest of this has to add up to 180, so that's 79. This must be 101 degrees. Okay, because this angle MPN is 101 degrees, and these two are a linear pair, that must mean that this angle here is 79 degrees. We should be able to double check that because this is the exterior angle to this triangle MNP, and it should add up to its two remote interior angles, and it does. 79 plus 73 is 152. 152. This should add up to 180, so 180 minus 152 should give us 28. Okay, and so now we have our triangles labeled, and so I'm going to redraw these triangles just to make sure that I'm talking about the right ones. We have MPR here, MPR, that's the one to the right, where we have 73, 79, 28. All these angles are acute, less than 90, so it's an acute triangle. MNP, MNP, right here. This is 62, this is 17, and this is 101. Okay, we have one obtuse angle. Okay, that must mean that it's an obtuse triangle. And here MNR, that's the whole large one. Okay, you'll notice there, and it won't mess up the problem though. Okay, so originally what they gave us is that this was a 90-degree angle, right? So we have that still 90. Okay, this angle's 28, angle R we'll call it, and then this angle is 62. Make sure that adds it to 180, and it does. Okay, and so here's our triangle. It's a right triangle. Okay, looking at these, you'd probably be safe to say that they're all scalene triangles, but we'll talk about why we would know that in later chapters. But the rule of thumb is if they don't give you information about the sides or they don't give you information about the angles, you cannot classify it by those. Okay, so here they're giving us information about the angles. We can classify it by its angles. All right, so that's the triangle angle sum theorem and classifying triangles.